thermal fluid sciences experts. This is ProReadyEngineer.
You see, density is very simple. It expresses mass. You see, density by definition is mass per unit volume, the amount of mass that you put in a volume. Not only mass, it's the mass in a unit volume, right? Let me try to make this easier for you to comprehend that story of mass per unit volume. Here's density rho. It's m over v, right? Mass per unit volume. Now, let's use SI units. You'll know why in a second. Put mass in kilogram and volume in meter cubed. And that will be the density in kilogram per meter cubed, a very famous unit to express density. Now, take the kilogram out and put it 1,000 multiplied by gram. 1 gram, 1 kilogram is 1,000 gram. So that's what we have here. Take the meter cubed and instead put 1,000 liter. Why is that? Because 1,000 liter is 1 meter cubed. Now, 1,000 goes to 1,000, goes away, and it turns out that the density is the amount of grams you measure in a liter. Let me repeat that. Let's look at this experiment here. What we will do is we're going to bring a jug, a 1 liter jug. 1 liter, it has to be, because that's what I just told you here. Fill it up. Measure the weight in grams. And the number it will read will be the density in kilograms per meter cubed. And these are all very representative numbers. For example, the very famous water here, water, 1,000 kilogram per meter cubed. Water density, 1,000 kilogram per meter cubed. Let me tell you how to build a feel for this. You see, if you have a 1 liter Pepsi bottle, you go to pick it. Let's say this is a 1 liter Pepsi bottle. So you go, you hold it. You don't have a problem. You did that because you know that the density is 1,000. So actually, this is 1 kilogram. That bottle, the bottle you picked, weighs 1 kilogram. It's nothing. It's going to be very, very light. You see, if you fill that same bottle, take the same bottle, put mercury in it. That's mercury here. And this actually, I lived through this personally. And it was a very day that I never forget. And this is why actually I'm showing you this example. So I was in the lab with my advisor. That story is about, 20 years ago. So I was with my advisor. In fact, it's more than 20. I was with my advisor about 25 years ago. And there was a bottle, 1 liter bottle actually. And it had mercury in it. So he said, grab this bottle of mercury, please. So I went to grab it. I went down and I'm holding it and I'm trying to pull it. And I felt that my shoulder and hand are being ripped off. It was, take a look at the number here. The density is 13,500 kilogram per meter cubed. What does that mean? That this 1 liter bottle was about 14 kilograms. Now think about that. Your perception, my perception, was that the bottle is 1 kilogram. So my body knows the amount of force it needs to pick 1 kilogram. I went there, I didn't think that I'm picking in the same bottle that I know it's 1 kilogram. It's not 1 kilogram, it's 15 kilograms now. The bottle, my perception is different. It's 15 times heavier, right? So density tells you, it brings into perception that the mass in a volume, so when you go to carry, to transport, and density comes for many reasons and many applications. Forces, buoyancy forces, forces on an aircraft engine, drag, lift, friction in pipe, pumping power required to pump fluids around, density will show up in all these engineering calculations. If you keep scanning here, you would build another field. Steel is about midway, right? Oil is less than water. You see, all those things are very important. Air is nothing. Air is like one. You know that 1 liter bottle? It's empty, right? It's nothing. It's 1 kilogram per meter cubed. So essentially, you know, the weight of the air is 1 gram. Nothing, essentially, right? Natural gas is even little lower than air. You see, in water, if you throw a piece of steel, we all tried that experiment. It sinks right away. You throw it in, it sinks right away, right? Why is that? Because the density of steel is much heavier than the density of water. You know, if you have piece of wood, you throw it in the water, it floats. Right away it floats. You know, why is that? Because the density of wood is less than the density of water. So I've just given you an example now of where density is important to know and understand in flotation, right? You will learn that in fluid mechanics. Okay, good.